Okay friends, so today we will start one of the most rearrangement reaction, that is Hofmann-Loffler-Freytag rearrangement. Okay, so first of all try to understand what is Loeffler-Freytag rearrangement. Okay, so in this rearrangement we have a nitrogen halogenated amines and which contain hydrogen atom at delta position. Okay, so are heated under acidic medium, then we get 5-member and containing heterocyclic derivative. Okay, so when nitrogen halogenated amines containing hydrogen atom at delta position are heated under acidic medium, then 5-membered nitrogen containing heterocyclic derivative will be formed. Okay friends. Okay, so let's discuss what is the general reaction for this rearrangement. Okay, so for example, we have R, CH2, 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 nitrogen, RTS, and this is chlorine atom. Okay, so this is called nitrogen halogenated amines. Okay, so this is nitrogen halogenated amines. Okay friends, in the presence of acidic medium, okay, we get 5-membered nitrogen containing 5-membered heterocyclic compound. Okay, so this is final product. Okay, so this is the final product. Okay, let's see what is the mechanism present here. Okay, so try to understand what is mechanism. Okay, so this is the general reaction. This is nitrogen containing okay, so compound, and this is nitrogen containing heterocyclic compound. Okay, so this converted into 5-membered ring. Okay friends, so let's discuss mechanism. Okay, let's discuss mechanism. Okay, so we have R, CH2, 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 nitrogen, chlorine, and this is RDS group. Okay, so in the presence of H plus ion. Okay, so in the presence of H plus ion, we know that nitrogen has a lone pair of electrons. Okay, so this lone pair of electrons attack to the H plus ion. Okay, so then after we get R, CH2, CH2, CH2. Okay, CH2, nitrogen. This is a hydrogen group, and this is RDS group, and this is chlorine atom. Okay, so when nitrogen gives one lone pair of electrons to the H plus ion, then it acts as N positive, because one lone pair will give to the H plus ion, so and nitrogen has a positive charge. Okay, so then after we know that in the presence of heat, okay, so we know that light, okay, in the presence of light, this nitrogen chlorine bond will okay will divide into two parts, that is two radical parts. Okay, so this bond shift two radicals. Okay, so nitrogen and chlorine bond will divide it into two radicals, then we get R, CH2, CH2, CH2. Okay, so CH2, nitrogen, this is hydrogen, and this is RDS group, and this is one radical here, and plus chlorine radical, this is already has positive charge. Okay, so this is the second step, and then after we know that this is the alpha position, and this is beta, this is gamma, and this is delta position, and in this rearrangement reaction one hydrogen exists in delta position. Okay, so this hydrogen shift towards nitrogen. Okay, so this hydrogen shift towards nitrogen by the help of radicals. Okay, so we know that R CH radical means one H radical will migrate towards nitrogen atom. So here will one H and one radical. Okay, so CH2 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 nitrogen, this is hydrogen and this is also hydrogen, this is RDS group and this is positive charge. Okay, then after we know that in our solution we have a chlorine radical, so this chlorine radical will attack this side of the radical. Okay, so finally we get CHCl CH2 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 nitrogen, this is hydrogen and this is hydrogen and this is RDS group. Okay friends, so in our solution we have a acidic medium H plus, then we have a OH minus. So this is OH minus will attack H plus ion. Okay, so this OH minus will attack H plus ion, then this bond shift towards this side nitrogen, then positivity charge will be removed. Okay, so then we get R CHCl CH2 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 nitrogen, this is hydrogen and this is RDS group. Okay, so we know that nitrogen has lone pair of electrons. Okay friends, so then after this lone pair of electrons will attack this side and this chlorine will be removed. Okay, so this is 1 2 3 4 fifth, so 5 membered ring will be formation. Okay, so this can also be written as 5 membered ring. So this nitrogen, okay, and this 5 membered ring, and in the position of 5 membered ring, so for example this is 1 2 3 4 and 5. Okay, in 5 membered ring we have a R group. Okay, so this is R group and nitrogen has a RDS group. Okay, so this is the final product for this rearrangement reaction. Okay, so this is the final product for this rearrangement. Okay friends, okay, so we will discuss some related questions about Hofmann-Loffler-Freytag rearrangement. Okay, for example we have a R CH2 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 nitrogen RDS and this is chlorine atom in the presence of acidic medium H plus. Okay, second is light and third condition is OH minus. Okay, so we know that this is a Hofmann-Loffler rearrangement reaction. So in this rearrangement reaction we have a 5 membered ring, nitrogen containing 5 membered ring. Okay, so we have a nitrogen containing 5 membered ring. Okay, then nitrogen has a RDS group, so this is RDS group, and in this is R in 5th position, so this is that. So this is the final product for this reaction. Okay, so we will take next example for this reaction. Okay, so for example we have a this type of question. Okay, so this is also a example of Hofmann-Loffler-Freytag rearrangement. Okay. Okay, so this is also a question. One position H plus ion, second position light, and third condition is OH minus. Okay friends, so these are the conditions and this is the substrate. So what is the product? Okay, so find out the product. So first of all, try to understand this is a Hofmann-Loffler-Freytag rearrangement. Okay, so how to find out this and how to know this is a Hofmann-Loffler-Freytag rearrangement. So first of all, try to understand this is a nitrogen atom and in delta position, like that alpha, beta, gamma and delta. So in this position we have a hydrogen atom. So delta position we have a hydrogen atom. So this is called nitrogen substituted amide. So this is called nitrogen substituted amide. So first step, we know that in acidic medium we know that nitrogen has a lone pair of electrons. Okay, so nitrogen has a lone pair of electrons. This lone pair of electrons attack to the H plus ion. Then we get this type of substrate. Okay, so this is chlorine, this is hydrogen and this is methyl group, then this is positive charge. Okay, so the next step, we know that we have a Hme, light. So we know that nitrogen chlorine bond will divide it into two radical parts. Okay, so this nitrogen and this chlorine atom, this bond divided into two radicals. Okay, in the presence of light, so we divide it into two radicals. This is nitrogen, this is hydrogen and this is methyl group. Okay, already has positive charge. Nitrogen has a radical and plus chlorine radical. Okay, so nitrogen chlorine bond will divide it into two radicals. Then after, we know that we have a delta hydrogen. Okay, so this is alpha, this is beta, this is gamma and this is delta. So delta hydrogen radical will shift towards nitrogen. Okay, then this radical will convert it into this side. Okay, so in this case delta hydrogen will shift towards nitrogen. So you know that this is nitrogen and this is hydrogen, this is also hydrogen, this is methyl group. Okay, so nitrogen has positive charge and this is radical. Okay friends, so in our solution we have a chlorine radical. So this chlorine radical will attack this side. So this is chlorine atom, this is nitrogen and this is hydrogen, and this is also a methyl group, this is positive charge. Okay, okay, so then next step will be, you know that OH minus, in third condition we have OH minus, this OH minus will attack H plus ion. Okay, this H plus ion, then this bond shift towards nitrogen. Okay, so then we get nitrogen, hydrogen, this is methyl group and this is chlorine atom. Okay, so we know that nitrogen has a lone pair of electrons. This lone pair of electrons will attack this side and this chlorine atom will be removed. So minus chlorine atom will be removed. Then we get, this can also be written as, okay, so this can also be written as nitrogen. Okay, this type of structure, and this is hydrogen, this is CH3 group. Okay friends, so this is the structure. This can also be written as, this is 6-membered ring, this is also 6-membered ring, and this is the bridging structure. So this is the bridging one. Okay, so nitrogen containing CH3 group. Okay friends, so this is the final product for this question.